Hello everyone, my name is Gagan H L from Visvesvaraya Institute of Technology. Under Emertxe, we have done implementation of washing machine using PIC16F877A board. So before I start with the project, I would like to give a small introduction about the project. Washing machine of late are becoming increasingly popular, especially in urban areas. Further, because of the availability of power in remote areas, also the demand of washing machine is likely to go up. A few years ago, domestic washing machines were popular only in metropolitan cities only, whereas now even in town area also the demand for washing machine is growing up rapidly. A washing machine is a home appliance used to wash laundry. The term is mostly applied to machines that use water as opposed to dry cleaning or ultrasonic cleaners. The user adds laundry detergent, which is solid in liquid or powder form, to wash water. It is an embedded system interface with external environment by means of several sensors and actuators. Washing machines are used to reduce human labor and save time. Microcontrollers and microprocessors are used to perform repetitive operation the same way time after time. We build a simple washing machine spin timer using microcontroller PI16F877A. Nowadays, we can see various kinds of washing machines, especially the fully automatic ones, as they are the front runners in Seoul. Customers want to have fully automatic machines instead of semi-automatics. Now coming to microcontroller. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. The design normally has restrictions on its memory size, input-output capabilities, peripheral functions. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Embedded systems can be categorized into these types: standalone embedded system, such as slave, example semi-automated washing machine; independent embedded systems, example Google car; real-time embedded systems, example airbag system, pacemaker; networked embedded system, example router, home security system; mobile embedded system, example Google car; hybrid embedded system, example robot. Now coming to components of embedded system. Here it contains a microcontroller or a microprocessor, and also the memory, and the sensor converts the physical quantities to electrical signal which can be read by the electronic sensors, or the sensor convert and measure the quantity to the memory. Then analog to digital converter, converting any analog signal by these sensors into a digital signal. It also contains a PGA, the digital to analog converter, which converts the new digital data which is given from the process to analog data. And also there is an auxiliary system which contains power or cooling systems. Also it contains actuators and diagnostic port. Here the software implementation is done by using MPLAB-XID, which is mainly used for algorithm development and integration, and also for simulation we used PIC16Lab. It is mainly used for simulation testing. Now coming to architecture of PI16F877A. It mainly contains RS-232 LEDs, buzzer, digital keypad, SSDs, matrix keypad, LM35 temperature sensor. It contains 12C RTC or EEPROM, and also GPIO. This is the PIC16Lab interface that we used in the project. So in order for working and writing the code, we need to know where will we write the code and we need to print. So we have to confirm that it depends on our target and development environment. So main.c have a main.h, where a main.c file used for the definition or define the functions and the variables, and it consists of all the data types, and it is non-shareable. H.file, here we declare the data type which is defined in .c file, and it is shareable. So module.c have the module.h and main.c have main.h. Next, moving to LED. LED is an external device connected to microcontroller port. A port is interface between the controller and external peripheral. Based on the controller architecture, there are n number of ports. Port is a peripheral and we need to know how to access it. This information will be available in datasheet in port B and port D and data memory sections. From schematic, we come to know that LEDs are connected to port B and port D. From the section of port B, it is clear that there is one register associated with it named TRISP. These are port B and port D connections. Here there is a general tactical switch which contains a metal plate and a terminal. When we press a switch, the two metal parts come into contact to short the supply, but they don't connect instantly. But the metal parts connect and disconnect several times before the actual stable connection is made. The same thing happens while releasing the button also. This bouncing effect can be eliminated by giving the delay. Now going to interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller where an internal or external device requires the MPU to stop the process. The MPU acknowledges the request, attends to the request, goes back to processing from where it was interrupted. Now coming to classification of interrupts. Interrupts are mainly classified into hardware and software. In hardware, non-maskable and maskable, and again in maskable, external and internal. In interrupt handling, here the super loop references the main program. When the main program starts executing, one of the interrupt will come to the main program, which is stored in the timer after the interrupt is executed. Then again it returns to the same address where the interrupt was called. Next, going to CLCD. CLCD means character liquid crystal display. In PIC16F, there are two types of display: 16:2 display and 16:4 display. It displays the ASCII characters and special characters. It is most commonly used display. Two types of communication modes are 4-bit mode and 8-bit mode. Now coming to timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Time or counter is a software designed to count the time intervals between the events. Resolution, which is also called register width. Scaling may be prescalar or postscalar. Now coming to simulation of the project. Firstly, to turn on the washing machine, we should press the button key 5, which is RB4. Now we have different categories of washing program, which are heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, daily, heavy. So now in order to select a particular program, long press the same key RB3. Now there are different water levels listed: auto, low, medium, high, max. Again long press RB3 to choose water level. Now we use the key RP4 to start and key RP5 to stop the process. If we try to stop the process by using RP5, it will navigate to washing program menu. If we press RP4 and start the process of washing, the motor starts running. And then if we press RB5, it stops the motor and also the timer, so the total process in the system stops. And again, to resume, we can press RB4. And here RB0 key can be used to give interrupt to open the door. And the washing process contains many different steps of washing, such as rinse, spin, so after the washing is done, you will get a message of remove clothes. Thank you.